Hey everyone, welcome back. So glad you could join us for another deep dive. We've been getting a ton of requests lately to really dig into AI.
Mm-hmm.
And I gotta say, I'm pretty excited about it myself.
Yeah,
It seems like everywhere you turn these days, AI is popping up.
right.
So I think it's high time we unpack some of these essential AI concepts.
Yeah,
You know,
totally.
we want to go beyond the buzzwords and really get to the heart of what this tech is all about.
Yeah, absolutely. I think a lot of folks hear AI and they immediately jump to like
Oh, yeah.
science fiction,
Yeah,
sentient robots taking over the world. But the
exact.
reality is much more nuanced.
For sure. And I think that's what we want to explore in this deep dive.
Definitely.
We've got some super interesting excerpts and articles here that you sent over
Yeah.
that really break down these core AI concepts.
Mm.
So let's just jump right in, shall we?
Let's do it.
First things first, let's talk about artificial intelligence itself. I mean, I have to admit, even for me, like when I hear AI, my mind kind of goes to those
Yeah.
Hollywood depictions,
Yeah.
robots that become self-aware and all
All
that.
right, right.
But I know that's not really what we're talking about here.
No, not quite.
So for those of us who aren't, computer scientists and engineers, what does it actually mean for a machine to be intelligent?
That's a great question. And I think it's important to start by understanding that
Yeah.
when we talk about AI, we're not necessarily saying that machines are thinking or feeling or being conscious in the same way that humans are.
Okay.
It's more about simulating or mimicking certain aspects of human intelligence.
Gotcha.
So things like learning, problem solving, decision making.
So it's like we're teaching machines to do things that normally require human intelligence,
Exactly.
but they might not actually be thinking in the way that we do.
Right. It's more about the outcome, the ability to perform these tasks.
I see. So it's not about replicating the human mind.
Not exactly.
It's more about replicating the results of human intelligence.
Yeah, that's a good way to put it.
And I'm guessing there are different levels of AI,
Oh, absolutely.
depending on how well they can simulate these different aspects.
Right. Some AI systems are very specialized. They're really good at one specific task,
Okay.
like playing chess or recognizing faces.
Yeah.
Others are more general purpose. They can handle a wider range of problems.
Fascinating.
Because we're still a long way from what you might call general AI,
Okay.
which would be a machine that can truly think and learn like a human across.
Right, like a true artificial mind.
Exactly. That's still very much in the realm of science fiction.
That makes sense.
Yeah.
So it's more about capabilities than consciousness.
For sure.
Now, one term that I keep hearing a lot in relation to AI is algorithms.
Yeah, algorithms are fundamental to AI.
And I have to confess, that word used to kind of intimidate me.
I think that's a common reaction.
Like, it sounds so technical and complicated.
It does sound a little scary, doesn't it?
But I'm guessing it's not as complex as it sounds.
Not necessarily. At its core, an algorithm is simply a set of instructions, a step-by-step process for solving a problem or completing a task.
So it's like a recipe.
Exactly. A recipe is a great example of an algorithm.
Right, you follow the steps and you get the desired outcome.
Precisely. Or think about tying your shoelaces.
Okay,
You probably don't even think about the steps anymore, but it's an algorithm.
I guess you're right.
You're following a specific sequence of actions to achieve a goal.
So algorithms are all around us. We just don't always call them that.
Exactly.
And in the context of AI, these algorithms are what drive the decision-making processes.
Yes, they're the brains of the operation, so to speak.
And they're getting more and more sophisticated all the time.
That's right. As we develop more powerful algorithms, we can create more capable AI systems.
Now, another term that's often used alongside AI is machine learning.
Ah, yes, machine learning. This is where things get really interesting.
Because it seems like machine learning takes algorithms to a whole new level.
It does. With traditional algorithms, we have to explicitly program every step.
Okay.
But with machine learning, the system can actually learn from data.
So instead of us telling the machine exactly what to do, we give it data, and it figures out the patterns and rules on its own.
That's the idea. It's like teaching a child to ride a bike.
Right.
You don't give them a detailed instruction manual for every possible scenario.
Yeah.
You let them practice and learn from experience.
So we're essentially giving machines the ability to learn from experience.
Exactly. And this opens up a whole new world of possibilities for AI.
How does that even work, though? I mean, how can a machine learn from data without explicit programming?
It's a bit complicated, but essentially it involves using statistical models
Okay.
to identify patterns in the data.
So the machine is looking for relationships and connections in the data.
Right, and then it uses those patterns to make predictions or decisions.
Wow, so it's like we're teaching machines to think statistically.
In a way, yes. But it's important to remember that they're still following algorithms.
Right, it's just that the algorithms are now capable of adapting and evolving based on the data.
Exactly. And that's what makes machine learning so powerful.
And we see this all the time in our daily lives, right?
All the time.
Like personalized recommendations on streaming services or online stores,
Yes, those are driven by machine learning algorithms.
or even spam filters that get better at identifying junk mail.
Exactly. They're constantly learning from the data they process.
So it sounds like data is pretty crucial to all of this.
Data is the fuel that powers machine learning.
But what exactly do we mean by data in this context?
It's any information that can be digitized and fed into a computer.
Okay, so it could be text, images, numbers, sensor readings.
All of the above. Even things like audio recordings or video footage can be data.
So basically anything that can be represented in a digital format.
Exactly.
And why is the type of data so important? Can't we just throw any information at these systems and expect them to learn?
Not quite. The quality and relevance of the data are crucial.
So garbage in, garbage out, as they say.
Pretty much. If you train a machine learning model with biased data,
Oh,
it's going to produce biased results.
makes sense.
For example, if you're building a system to identify job candidates,
Yeah.
and you train it on data that only includes successful candidates from a certain demographic,
Oh.
it might inadvertently learn to discriminate against other groups.
So we need to be very careful about what data we use and how we use it.
Absolutely. Data ethics is a huge and growing field within AI
Rightfully so.
because these systems are only as good as the data they're trained on.
Now, one more term that I wanted to ask you about is neural networks.
Okay, neural networks. These are the real heavy hitters in the world of AI.
I mean, they sound super complex and kind of futuristic.
They do, but the basic idea is actually pretty intuitive.
Okay, I'm all ears.
Neural networks are inspired by the structure of the human brain.
So they're modeled after how our neurons connect and communicate,
Exactly. Imagine a network of interconnected nodes.
like a web of interconnected points.
Right, and each node represents a simple processing unit, kind of like a neuron,
And how do these nodes learn and adapt?
through the connections between them. The strength of these connections
Okay,
can be adjusted based on the data that the network processes.
so it's like the network is constantly rewiring itself as it learns.
In a way, yes. And this allows neural networks to learn very complex patterns.
And this is how they can do things like image recognition or language processing.
Exactly. For example, in image recognition,
Yeah.
each node in the network might be responsible for recognizing a small feature.
Like an edge or a curve or a color.
Right. And as the image is processed through the network,
Okay,
these features are combined and analyzed at higher and higher levels.
so it's like a hierarchy of feature detection.
Yes, until the network can identify the entire object.
That's incredible.
And the same principle can be applied to other tasks, like natural language processing.
So it's like we're building artificial brains that can see and hear and understand language.
In a sense, yes. But it's important to remember that these are still just mathematical models. They're
Yeah.
not actually thinking or feeling.
But the results are pretty mind-blowing nonetheless.
They are. AI is rapidly advancing, and we're only just beginning to scratch the surface of what's possible.
Well, this has been an absolutely fascinating deep dive.
It's been a pleasure.
I feel like I've learned so much about the fundamental concepts of AI.
Me too.
And, it's amazing to think about all the potential applications.
Oh, the possibilities are endless.
But it also raises some important questions about the future.
For sure.
Like, where do we draw the line between human intelligence and artificial intelligence?
That's the big question, isn't it?
And what does it mean for us as a society as AI continues to evolve?
It's going to require a lot of careful consideration and ethical reflection.
Absolutely.
But I think it's also an incredibly exciting time to be alive.
I agree.
To witness this technological revolution firsthand.
So for all of you listening out there, we hope this deep dive has given you a solid foundation for understanding the core concepts of AI.
It's just the beginning of an amazing journey of discovery.
So keep exploring, keep learning, and keep asking questions.
And who knows, maybe one of you will be the one to develop the next breakthrough in AI.
Until next time, happy exploring.